Welcome. Welcome to part two of our little MMU MMX journey. Yes, we left off last time with a bit of like a stiff assembly, or like the mechanics were a little bit stiff. I did solve the problem actually after like sitting down for like another half hour. And I think I found the issue. So this like turns now very smooth. Like it's not like free spinning, but I don't think this is possible. But what the problem was is that the through holes, basically where the shaft goes through, they are modeled with I think 6 millimeters, if I remember correctly. And basically, I think because I printed the parts in ABS, there's some ABS shrinkage, and that just caused basically the shaft to slightly touch the printed parts. It's still, I think, a little bit touching. So I drilled it out with a 6 millimeter drill bit, and it's still not fully free. So I think this is still partially where the friction comes from. But I also checked with this video tutorial. I forgot the name, like this guy uploaded, and also for him, like it was relatively hard to spin. Like I think he used pliers to spin it. And I think mine is actually moving more easy than his. It's most likely this will also wear in a little bit. So this will be, I think this is fine as it is now. So I did this, and then the other problem was basically that the shaft here. Hey, Mr. Desai, welcome. Hi there, Eric, welcome. The other problem was that this shaft of this camshaft, like the metal part inside, did not allow, or like did not fit in the bearing here at the end. So here's like this bearing at the end. Let me actually like zoom in a little bit. So there's this bearing here at the end, and this shaft did not fit. Like now it does fit. But I actually tried the other shaft, which is the same shaft basically. And I tried this one with the bearing, and that worked perfectly. So I knew that it was this shaft here. So what I did is I assume the shaft must have been like tiny bit oversized. I just put it in my drill. Basically, with the drill chuck, I just clamped it down, put a bit of sandpaper on the table, and just like use the drill to like rotate the thing over the sandpaper on both ends. And that was 20 seconds, and now it really fits in, no problem. I potentially overdid it a tiny bit. It's not loose. It doesn't really have play. So I think I have quite okay dimension now. And yeah, this rotates now. I mean, here there's still something missing because there's this shell part. I kind of use it as a container right now, but there's a little like a hole here for another bearing. And that's where the end of this shaft goes in. So during the construction now, or like while we put it together, this is a little bit unsupported, which I find interesting. But yeah, this is kind of how it's designed. And what we can do now, if we put these down. Hi, Steve. Welcome. There's a bit of like a maneuvering challenge here, but so basically you can see now, so now the first gate is engaged, and if I rotate over, basically the second gate, and then the third, and then the fourth. So this camshaft basically depresses one of these gates, and I think that's actually what we will start with now. We still have to install the counterpart basically of the tooth bearing here on the bottom. So basically one of these will be pressed down by the camshaft, and the others, due to the magnets, will float. And the one that's depressed basically will then engage the gears and drive the filament. So let's actually just start with that. I think that's something we should have done like quite a while ago, before installing these flaps, but hey, better late than never. I think the general recommendation is to use a teeny tiny bit of grease. Let me just unpack them all. Let me grab my grease. And I'm just going to use the exact same that I would also use for the motion system of the printer. And I think what I will do is I will just put a minimal amount. It doesn't have to be a lot. Like I think less is better here. Teeny tiny drop there, and that will work itself in. And the just goes. Should start with this one. This is easier before installing them. Okay, that's the first one. Second one. And one more. And the other thing we should do, I think the thread locker the thread locker on the counter part of these is most likely not good. So I think we should reapply the thread locker there. But now if I engage them here, yeah, you can see the gear spin here. We can drive the filament. So that is working. Good. Yeah, then for here, I think, yeah, these only have one screw. So I'll just quickly take the screw out, dab it in my thread locker, and then reinsert it. I'm actually not sure if we actually applied thread locker to those yet. There's also something I noticed. There's basically no space. No space between the gear here and this plastic part. I actually filed a little bit away there, but here you see, for example, it touches pretty much. So I'm always trying to align them a little bit more towards this direction, that they don't touch the plastic, because that of course causes friction, and we don't want friction. Oops, that was way too much. actually should remove that a little bit. How do I remove that? Okay, good enough. Okay, then is this complete? Then I think we can insert this now for good. And if we engage 3 here, so I'm just holding 3 like down now, we can drive the filament. And if I hold 2 down, nothing happens, but it doesn't sound. Yeah, no, it's better. Okay, I had to groove in. Okay, so then that kind of brings us to this side, which is more or less, I think, mechanically the last thing we need to do. We have 2 belts. One is 184 teeth, and the other is 188. We need to quickly figure out what goes where. One is relatively straightforward. I think this actually 188 goes here. We just connect these two, and then we can use the position of the stepper motor here to tighten the belt. Let me go double check before I like do something that I have to undo. Yeah, so this is the 188. So let me just put this on here, and now we can just rotate or like force the stepper a little bit down to potential, but we don't want to have like too much tension here, right? Just a bit. I think actually the screws are too long. Yeah, the screws are too long. We need shorter screws. Like you see what we used there. I think these are M310s. Do we have that here? Yeah, M310. I think we need M38. We quickly swap that. Leg stuttering. Oh God, I didn't check the messages. Leg stuttering. Yeah, getting it here also. Yeah, just looked at the stats and 0 drop frame. Shaft needs. Yeah. Poor to watch all over the place. Poor to watch all over the place. Let me see what's up. Let me see what's up. I'm not sure if my internet has a problem. Yes, my internet has a problem. Okay. I think now it's sorted. Is it now better? Do I still have viewers? Now it should be solved. Still there. It's still lagging? No, it can't be. Because now I had So basically, I had VPN on accidentally, and I had a lot of dropped frames here in OBS. Now I see 0 dropped frames and 22,000 kilobits per second. So this should be fine. Maybe it needs a second to like groove in, but the stream should now be high quality as per usual. Sorry for that. I'm not having a run at the moment with technical issues. Can somebody confirm that the stream quality is better? Not dropping here now. Yeah, yeah. Okay, then I think I fixed the issue. Sorry for that. That looks good. Also, your internet speed is not super high. Well, now it is high. Now it is high. Um, Now it is high. Should be like yeah, 600-700. So this is plenty for streaming. 600. Well, this is what I pay for. I pay for 1 gigabit. So but I do have a firewall and stuff like that, so that reduces a bit. All right for streaming, yeah, exactly. This looks good. There's a maybe you can like reduce the tension even a smidge. Yeah, I think this is good tension. Okay, for this one, there's something funny. So I printed the parts as per the printables, I think it is. And you can see that these 2 gears here, it's black and black, so maybe a bit hard to see. But these 2 gears are not aligned. Like, I mean, I can basically show you here. So if yeah, you see here it's like basically flat, and here it's standing out. I did print. I did print another gear for that reason. Or did I forget to print that? That would be hilarious. I think I forgot to print that. Oh, let me have to quickly print it. No, seems like I forgot. Like either I lost it or I forgot. But yeah, so these are not aligned. I'm not the only one having that issue. I just have to find the model now again. Well, that is hilarious. Let me quickly take care of that. Time for the V0 to save today. Yeah, let's quickly look up the part on printables. MMX MMU, why are you not showing up immediately? Printable search being drunk. I saw it in the comments that somebody had the same issue. Here. So this is exactly the issue I have. And Sweeney, this one fixes it, which is a 404. Here. There you go. Let's quickly put it in the V0. Loki knows where it is. I do have the suspicion you have a pointer. Yeah. In 20 minutes, we will have it. 10G symmetric. I think 10G symmetric is not the average. Let's put it like this. I think the fastest I can get is 2.5 at the moment. But like it's quite expensive. And I don't need it, to be honest. Like one gig for me, symmetric is more than enough. Yeah, I also don't have 10 gig network infrastructure, so that would be complete waste. I only have 1 gig here in my home network. Okay, so we have to kind of wait for this pulley here. But I think we can already kind of like attempt to do the rest of this run. Because there's also this part here. Oh, my camera is also a little bit funny. It's faster. I can look at wait. Look at your downloaded model. Why should I look at my downloaded model? Do you think it's the wrong one? There's extra space here, so I think it's the correct model. Or do you mean the Fusion? Okay. We have here this little tensioner. I do want to take a quick look in Fusion, maybe, or not in Fusion. We have the manual. Let's check the manual. How this goes together. So where's it described? Doesn't seem like you have a specific description for this either. So it has basically 2 bearings there. And we do have here, we have this bag with bearings. And I assume that just goes in there. And looking at the spacing here, I don't think that we need any washers there. There's not a lot of space. Let me take a look in the Fusion what they have in mind here. Oh, and the Fusion did its thing again. I really wonder why this keeps happening. That like the Fusion freezes and I have to do one time this. Let me just hide this thing here and then yeah, it doesn't look like there's any washer. So it's just like the 2 bearings here. Just the 2 bearings. And then we have 2 screws that basically go through the whole thing. I assume that's no, 30 is way too long. M320 is the winner here. Oh, there was to find the yeah. Check. So might be actually a little tiny bit long. Might be a bit long. I don't think if I have any. Oh, I have M316. I think maybe on the back we use a 16 instead of a 20. Because the back is a little bit shorter. They definitely didn't save on the hardware. Like the bearings and stuff is like all exactly what you need, but screws you have plenty. Okay, and where did I put the belt now? Okay. So the belt basically goes around this, and then this is kind of like, honestly, I'm not a mechanical engineer or something, so I have no clue what this is supposed to do. But we can later also like move the servo a little bit down to tension this entire thing. And then this, yeah, kind of like you can pull the whole axle down, until like the back part is there. And then looking at the cuts, we have these like spacers here that go here in these to kind of space it out, I guess. Okay, this will take like 20 minutes, I think, until we have this part. So I don't think we can complete the mechanical part here, but I think this is actually the last thing to do. What we can do to try in the meantime is insert the bearing here. And if I put this on here, it should go into the bearing. Check this out. All right, it does fit in. I think you just have to align it really well. Just want to make sure not that the shaft is too thick there again. Is it an undersized bearing? No, the bearings are actually fine. I explained it in the beginning. So basically, this shaft and this shaft are exactly the same. Like these are exactly the same. And I have one spare bearing for whatever reason. The bearings fit well on this shaft. This is not a problem. Like they fit perfectly here. Only on this shaft, they don't fit well. And what I did with this shaft is I just put it in the chuck of my drill, put sandpaper on the table, and just used the drill like to kind of like spin the shaft over the sandpaper to like I don't think I removed much. It was like 20 seconds, and then it fit perfectly. So for me, it looks like this one shaft is oversized. Also, the funny thing is now the bearing fits at the end. The bearing fits at the end. But here it stops. Like I can't push it over the spot. It's impossible. And also from the other side, like there's like just like a spot. I can't push this further than this. So I think the shaft is just too thick in one spot. Oh. Yes, I reprinted this part was a little bit warped, and I reprinted this one. It's way better now. And also like the friction is gone. And I also sanded the in between the parts here a little bit, and now also this extreme like shape like this is gone. So now it's just a question. Can we? Yeah, here now it's in the bearing. That will be quite fun to put this together later. I mean, now it's kind of together. But what's funny now is I can't fully spin it. Like there's a stop now. Why can I not fully spin this? Oh, yeah, I can fully depress all of them. Okay, now it works. Don't ask me why. But yeah, so we later have to put this all together. While we're waiting for the part here for the belt, maybe we can start the wiring a little bit. I think that's kind of like from the hardware build perspective, the last thing that's missing. So we have this module here, like it's kind of like they call it slat. This just goes in here, which I find quite neat. So we can assemble all the electronics here and then just slide it in. Let's just start with the buck converter. So that goes here, and I used the wrong heatset inserts here. M3x4 button head screws. I think these are the exact thing we need here. Oh, they have fun. But actually, before I do that, so we have to steal 24 volts somewhere. I kind of want to have this like as a kind of like clean wiring job. That means we only have two ports here. One is the USB and one is the CAN bus header. One is the CAN bus header. So this, I guess, goes in. Yeah, this direction. So the question now is, my idea was, because here we will have 24 volt and CAN bus. So I kind of want to like leech off that. My first idea was like we can just solder to that, but it would not be super nice. My second idea is, and I think that's a way smarter idea, is we just use the screw terminal here and just basically turn on the servo by just setting the pin of the, like this for the hot end. So this can definitely provide enough power for the servo. So basically we need to solder two wires on here that then go over to the screw terminal. That was kind of my idea. So like, let's first solder the wires here. And what I would do is like, I think for the inside, we can just solder directly wire. For the outside, I think we should have like maybe a JST or something that you can disconnect it. So let's just do that. And then while we are soldering, I think we should also solder already the LEDs because then we have all the solder work basically out of the way. And this one is doing a thing. So it was warping a little bit over extrusion. Yeah, could be. Lift flap 0 and center the idler gear. It's off to one side. No, the idler gear looks fine for me, Steve. That looks pretty good for me. Once you have it. It's a bit annoying to feed through here. I'm not quite sure. I think it's because you hit the ECAS from the back. But like this, this works well. Okay. Let's do this one first. This is easy. Let's just use the wiring they give us. Red and black doesn't have to be super long, of course. It's a very short one. Oops. We want to wire it to the inside. And I'll just put the bare wires through the hole. And then we'll just drown it and solder it. Yep. Also, either gear shaft must have centered itself. Oh yeah, that could have been. Oh, that's most likely why it didn't close properly. Yeah, check. Okay, that's one. The other one. Just do it like this, and then let's also solder the outside already, and then we can put some connector on there. Okay. Let's quickly finish this one up so we can put this on here. Now I thought I cut like a generous amount of wire, but it's ooh, it just fits. Now, which one of those two is plus and which one is minus? Because it's meant for a hot end, it's not explicitly labeled. Let's see. So this is the plus pin. According to the label on the board, just a plus here. Yep. I would have expected one of the two to have like a connection, but neither has. Oh, oh, the screw does not have a connection. Okay, so this is the outside one is the plus. That is very handy for us with the short cable. Oh, fully closed. Perfect. Now, like basically, we can power everything from one plug. Let me quickly see. There should be some screws in here. Maybe, maybe not. I don't think there's screws in here. I think these are just the connectors we can use to crimp. Now we'll just put it in here. Nope, they don't give you screws to mount that. Let's use M36. I think these are the shortest ones I have. Should be fine. Yeah, M36. Perfect. And then I think we can, like, when we flash Clipper on this thing, when we flash the firmware, we can just set their pins to set at startup. We just need to figure out the pin, and then we can set the pin at startup directly, and then fire and forget, basically. Yeah, I think we could have also used. I'm still a bit confused why, like, officially these two are shorter heatset inserts than the others. That's not clear to me. Okay, so you can see the plug here, but there's generous spacing. The right length on first try, yeah. You know, like I'm always thinking like leave lots of extra cable that you definitely have enough, and then like this is how it ends up. You're going to have to run 2 pins in the config now, one to give power via heater, another for signal. Exactly. I mean, the heater pin, I will just hard code basically in the firmware. Because like it's just, yeah, we just turn it on and then that's it, right? Like we don't have to turn the power off from the servo. But basically, the server has 3 wires, and one we will connect somewhere else. So to be decided where. Yes. Then for these, I think, I mean, technically you can just directly solder the servo wires on that, right? I think red and brown. I will just use like a 2-pin JST now. I'll just quickly solder that. I'll just quickly solder it together. Let's get a little heat shrink. I think I lost my lighter. Okay. I'll grab a lighter later and shrink those. Okay, but then that's kind of like the power side of things. Let's move to the LEDs to solder. Because then we are done with all the fun soldering stuff. The print is done, by the way. Let's quickly take a look at that first. Oh, yeah, see? That did not work out. But let's quickly check if the rest works. I think now it's quite aligned. I have to reprint this again because like there's some didn't touch there. It's still too low. That is funny. Like it will not work. But the belt is definitely not straight. And not straight by quite a bit. Because if I look at this, here we now are like 4 millimeters from the plane. And here we are like 6. So we're still 2 millimeters short on this one. That is interesting. I wonder, because I added these rubber thingies here, on the servo. I wonder whether it's because of those. Let's quickly look at this before we solve the LEDs, because I want to print the new part, and I want to know if the new part is correct or not before I do that. Let me just because I added these rubber pads here, and they do add a bit. So I wonder if I remove them, if it then fits. And I think the best strategy to put them on, like thinking about now, is just to put these screws in here. Put the washer on. Okay, so I have the two nuts on. And then my idea was like, because these are open, maybe I can just exactly put this on. It brings it a little bit forward. Yep, and now it aligns. Now it's okay. So the part is okay, I just have to reprint it. Is it okay? No, it's still a little bit too short, I think. No, it's okay. That worked. Okay, so we have to install without these rubber pads. Let me put on the servo again. There's my nuts. Where did the washer go? -1 washer. There's one spare. Not quite sure if I dropped it or something. Hi, Torsten. Welcome. Quickly remix it with 6mm offset. Yeah. I mean, that was the plan, but now it does fit. The only problem is now I don't think I will. I'm not sure how to put this stuff on there. I know I don't have my tweezers here. I'm very ill prepared. You should definitely do this before installing the rest. That is my recommendation. Let's see what we do. Pliers, so I can use those. And then I should also be able to use some that works. And now this also slides up and down quite a bit, so that's good. Not tightening this now fully yet on all, but we know this part works. We just have to print it one time without defect. Let's try this one again. And while this is printing, we can. I found my missing washer child. Okay, then back to the LDs. So the LDs are a little bit funny to solder, I think. They do have exactly. So you have to kind of solder it vertically, because these like slide in into these pockets. I think we're supposed to use these thinner cables here. So let me see. So they also have direction, of course, so we need to be careful with direction. So this one, if we start with the last one, I have to solder this like this. Let me just tin up the pads a little bit first. And then my question is, how long does this cable need to be? So you kind of have to go from. We have quite a lot of space here, so I think it's better to leave the cable a little bit longer because it will make it a lot easier to install. Technically from here to here. So let's go with this this length. So this will be like kind of like my template. Okay. And I need 3 of these pairs, and the last one needs to be long because the last one goes to the main board. Okay. Then let's start. Just removing a bit of isolation on both sides of these. And then we just have to kind of solder them vertical. Let's see how it goes. And that seems to work fine. But I should start next time with the red one, because then I have space to work with my right hand. Okay. I also should pre-solder them. I think it was nicer if I pre-soldered them. Like add lead to them first. But these are fine. Let's just do the other side a little bit different. Maybe it's also nice. I can now just like cut into the same length here. So let me do what I just said and just add a tiny bit of tin to all of them. Okay. Then the next one. So we now have to solder these wires to the output side, so the side the arrow points to. And then I have to indeed start with the negative, just to make my life a little bit easier. So we start with the negative. Okay, so that's our first loop. Then let's do the other side of that. We need red, black, green. We just put all these. Oh, we also said we want to cut them to the same length. So I'll just tin up one side, and then we cut them to length, and then we tin up the other side. And this time I start with red again. Be careful that I use the correct side. Okay, now I can cut them all to the same length. Yeah, now it looks better. The printer just started. Okay, then we need to pay attention to the arrow again. So now we solder to the output side. Which means we start with black. I don't like how the green is. It's a bit to the side. Let's see if we can touch this up again. Now it's okay. And I kind of like creating like a little loop. So almost done. We start with red. Cut them to one length. Do the ends. I'm happy that we don't have like 16 gate happy hair. Not happy, ERCF. Then I think this, does the ERCF have LEDs? I'm not sure. But if yes, this would be quite a task. We solder the output side, so the arrow points. That means we start with black. And that's the 4-chain LD. So the last thing missing is basically just the connection to the main board. I will just solder the rest of the cables that we have on there, and then we can just see how long we need them later. Okay. Start with red. That did not work. And that's the last one. We have a nice chain of 4 LDs. Let's see. So if we start here, That looks good. Like it's a relatively long chain now here, but to be honest, like there's more enough space. It's easier to have it longer. And yeah, they're relatively easy to slide in and out, which is, I guess, good. These parts are the diffusers they go over. They are really tight. So if I put this on, it will be kind of like a one-way situation. So I don't want to do that yet. I don't want to do that yet. I first want to see that the LEDs work before I kind of like embed them in here. And then the fuse go on, and then we have this mount that I designed, and that case goes over here basically, and then we mount it on top of the switch wire. I think the LEDs will fly out like 5 times, but that is okay for now. Okay. Then that was all the soldering. Given that everything works, let's return to our little journey here. So basically what we need to connect is one servo, one stepper, 4 switches, and the LEDs. I think they do have some suggestion how to wire everything up, which is here. Do you use PEV cables? Yeah, these are silicone wires. They came with the kit. That is exactly what I will use. But I also use silicone wires in my other printers usually. Loki, yeah, Loki is better. But I did park him at my neighbor again. No, he just ate a plant, and he was like horribly off the entire week. Like he ate a plant on Monday. And he was like already like Monday evening, he was a little bit off. Tuesday he was off, and Tuesday he didn't eat a lot, and then Wednesday he didn't eat anything. Thursday he was like he had diarrhea and was throwing up. He didn't eat anything on Thursday. And then Thursday we also went to the vet, and then Friday he was also like really bad. And then on Saturday, Sunday, like he started eating again, like a little bit. Yeah, he's fine now. He lost like 150 grams, and the vet is very happy about that because she told me that he was a bit too fat. So now he has his ideal weight. So hey, yes, let's just see with the wiring what we need to wire here. So we need to wire up the LEDs, and this is thing like here's this gate sensor. We don't have the gate sensor. That's just like it's an old manual. That's really that was like eliminated at some point. We do have the 4 switches, and I would suggest we just start with the switches. This is this one larger. This header here. This one. So I would wire up this one. And then the servo goes on this header here, but only one pin, right? And the 3-pin header here is the LEDs. And the stepper is just a stepper. I do think we will shorten the stepper cables though. But let's just start with let me actually remove the LEDs for now again. We have a lot of wires flying out here. Let's just start with the end stops. And now I see like that one end stop goes to a different connector. That kind of sucks, but it is what it is. So I kind of want to have like a easy time plugging this in. So I think cable length wise, we should be somewhere in this this direction. Then we can like plug it in here very easy. You have a bit of like play, and then you fire it in. So I'll just do the following. Actually, let's just I'm thinking if I should like kind of like twist these cables together or like braid them to make them like one. But now let's just leave them like that. So let's just use this as a length. That's quite a comfy length. And then we need to put this like 3 of them, and there should be a black cable as well. Ah, perfect. And I'll pull the cables a little bit different, and they're already like complete different lengths. Perfect. So these are the switch cables. One ground that connects to all of them, and then yeah, this looks how it's supposed to look. We will install in a second. Okay, so one cable we leave out because it goes to a different plug. Yeah. And that's just an extremely small JST. I'm kind of missing. They give me the housing for the plug. Oh, it's this one here. Yeah, this is the housing. Yeah, but they don't give me the crimps for that. I mean, there are 5 here. That's funny. It's like, here's a connector housing. Let's use these 5. We have one shot. I have some more here, but I find it funny that they're like really strict with this. Okay, I will just do it like this. I think that's the most convenient for me. And yeah. It's quite a thick cable for these small connectors, but I think it will work out. And then this one, I'll just put it in a PDF YouTube. That's the one we will do later. Okay. The silicon wires is relatively easy to crimp. Yeah, JSTPH. This is JSTPH. I hope so. Yeah, should be JSTPH. Let me quickly see. I just want to quickly check that like I can insert that before I crimp them all. So we can start from here. Yeah, it's JSTPH. But now I have to get my tweezers. I used them for something else. They're not here. I quickly get them. 1 second. Here we go. Okay. Yeah, that looks good. Yep. Okay. Then Let the crimping begin. So the three switches go next to each other in the plug, and then the ground follows, and the 5-volt in this connector is kept free. Yeah, okay. So I was trying to keep the order. Okay, this is one connector. This one goes on the same connector as the servo. So this we can also already cut somewhat to the same length. Yeah, it should cut. And the yellow cable is the signal, so I remembered it correctly. So these two will share one connector. And that is a JST, not a DuPont connector, which they give us neither a housing for nor the pins. I think that's important to remember. Oh, that's a 4-pin. There's a random DuPont connector here. That's a 4-pin. We need a 5-pin. Let me 4, 5. I have here. But we can use. It's I think important to know that you need like a little bit of these connectors available. Did not go well. Like sometimes it twists the connector in the pliers, and then it's not a good crimp. No, it's also not a good crimp. Okay, good enough. Then there's no orientation to this connector, so I just start one is all on the outside. and then one free, and then the other. And then one free, and then the other. Okay, so that goes here. Like, yeah, this one is not good. Like, I have to redo the yellow one. Like, it holds, but like the connector is a bit crippled. Let's try this one more time. Is it me or is it the connector here? This just doesn't hold. The green one is fine, but the yellow one is it's like it doesn't click in, like the nose is not there. Like the let me try one of mine. Yeah, they look a bit different. Interesting. There's like a cut missing here. Like the nose is not disconnected. I wonder if they're just like a bad batch or something. Yeah, now it's in. Okay. Then for these two, that's power and ground for the servo. We need to crimp a normal JST connector. That matches then basically this one here that we did. Tell me, didn't use the microfit ones. No, it's in there. That's the correct ones. You just need to put for servo. The other two, yeah, and for the RGB, yeah, and for the RGB. It's a little bit of everything because it's not like a JST XH. It's like every connector once, basically, just to keep it a little bit interesting. Yep. Crimped a little bit too far on the back, so the front, I don't know how they call it, tongs, arms. were not crimped. I wonder why they use brown for the servos. Mm. Okay, so this is also connected. Then this one we will definitely shorten because that's like quite the thing. I leave it a little bit longer because it's on the other side of the board. And I should just reuse the connector, but no, I will leave the connector on, then we can just copy the pin out. And that's the same connector we just had. So it's a JSTXT. And I think after that, we only have to do the RGB connector. Why do you not want to say it? That's a bad one. Is it bad? It's okay. Okay. Then I need JST4. Cool, which I don't have. Here's one. Just copying from here, so it's blue, blue, red, green, black. Okay, this is also wired up. And then the last thing is the LEDs here. So I'll just put in the first one. Just throw the cable through here. You can like put them roughly to the same length as the others, I guess. And then this will be one of these as a 3-pin, yeah. I will just reuse the housing actually of this one. Oh. DuPont. So let me quickly first. If I can rescue that. This one is stubborn. Okay. Also seemingly very critically low on female DuPont connectors. There's one. It's JST, XT. They're all a little bit like 2, 3. Hey, that's work. Okay, that's 1. 2. And last one. Okay, then what's the pinout here? I mean, it doesn't matter because there's no orientation to plug, so the data is in the middle. That's the only thing to pay attention to, and the rest is fair game. Perfect. Okay. Let me clean up a little bit here. But I think we are complete with soldering for sure. And we are complete with crimping as well. I don't think we have any other crimp jobs. This can all go. This we need to keep. Yeah, whatever. This can all go. Okay. Then we have one more belt to do here. Mhm. I think this screw is not too short. I hope it comes out again. Also, I do miss my reamers as well. I'm missing like some random things here. Let me see. Maybe like M310 should be a good one. No, it's too long. Let's do M38. Yeah, perfect. M38. Then we have the belt. Goes around here. Now, just like checking if this is like kind of like in a, yeah, this is fine. So I think we can fix the servo in this position. I'm just going to use like a flathead screwdriver to kind of like prevent the nut from twisting or turning. Okay. Then for the servo, like this is now like the most position turned to me. So that will turn over this direction to turn. So I need to kind of connect the belt now in a way that if I turn this direction, I can. So like maybe we need to select 0 now, and then it can, let's just do it like this. Oh, okay. So I have to pull this up a bit. But if now the servo turns, because servo only has like 180 degrees of rotation, so we need to be careful how we position this. Yeah, so this is now the end position. And this is the end position. So now the end position is kind of like a pressing gate 0. And we can go through all gates. So this is okay belt-wise. Then I would say let's try to put this one on. I'm not quite sure what kind of screws we need here. I assume 25s. Maybe 25 is too long. Maybe it's even 30. Yeah, I think it's 30. Like the 25 doesn't cut it. And 30 we have we have exactly 4 30s. So I'll take that as a sign. And we also need these spacer things here. Yeah, I think this is good. No, it's too long. Because the spacer, I expect touches. So I think 20, 25 is better. Worst case, we just have to try it out. Yeah, this is yeah, 25 is way too low. Now we need 4 of these. But this is not a 20. This one looks a bit rough. This one looks a bit rough. There's quickly file this down because like they kind of need to go into like a little bit of like cutouts there. Otherwise they're too long, I think. Not quite sure why this one has a bit of a problem and the other is not. Or is this longer? Hmm. The screw is the same. Yeah, it's a stud. Like it doesn't go into this like little easy enough to fix. Something's off with this one. Yeah, it's longer. This is longer than the others. Which one would be longer? Should be all the same. Hmm. It's funny. The others are too short, I think. Because like here it doesn't touch. So this is the one that the troublemaker. And like the screw is too short for this one. But like here the screw is like clearly too short. So I think it is the M330 part screws here. And for whatever reason, my studs are a little bit too short. I think they're just to guide the screw, like to make it easier to screw into the hole. I was not quite sure why they're like separate parts. Like you could just have added that to the printed part, you're right? Like why make that a separate thing? Okay, one more attempt. Yeah, it's definitely the M330. I think not easy to print. The standoffs will be weak. Yeah, that is true. That's also like maybe they don't want to print it in one go because like they fear standoffs can break off. But here it is. Mechanically, it's complete. By the way, so Faith No More, I think on the Discord had like massive issues with like grounding in Canvas. And now see there's this ground cable here, which I assume is a ground cable for the stepper motor. Just like observation. Okay, cool. Yeah. This means this is all kind of complete. I think we can also close off this side technically. Technically, there's a little bit of a. I think I have to loosen these screws to get this in. Because these panels kind of like hook into each other a little bit. It doesn't align perfectly for me, but it goes together. We have a bunch more of those. Yeah. Oh, Thing ate my screw. Oh, we can't do that yet. We have to first do the LEDs. First, okay, that was funny. First the LEDs. Where did I put the LEDs? Did I trash the LEDs? Yes. Maybe we should keep them for a second. So they go in here. I'm a bit afraid of like closing them off before testing them. So I will not put the diffuser on yet. But now we can just push the diffusers on if everything works, which is what I assume to be the case. Okay. So there's one more panel basically that closes off everything from here. But before we can put this on, we have to, of course, wire everything up. So this one is easy. This one goes here. I still have to do the heat shrinks though later. So this goes here. Then this plug, let me make sure that I kind of have an orientation. We also move it in later. Goes here. This plug goes here. That's the stepper that goes over here. And the LED with 5-volt facing the type C. Goes here. And what we forgot is the little heatsink for the stepper motor. So I'll just pop it on now. And then we can put the whole thing in. In retrospect, we could have left the cables like 2 centimeters longer. And this should now fit in like this. That's it. That is it. Still a little bit of a warp here. Like it's, I think, relatively hard parts to print in ABS, to be honest. But yeah, it fits, it works, it's good enough. That also spins. Okay, let's quickly feed. Oh, yeah, that's the thing. Like with the if there's no bone tube in, like they can catch the teeth. But this works. This works. Cool. So, let me think. Ah, there wasn't quite in. Okay. This a bit more. Yeah, I'm not a huge fan like with these parts. They all have these like grooves that fit into each other. Now here, for example, like it just like cracked the part when I did that. I was like, yeah. But yeah, that is just some minor visual issue. Let me see. But yeah, these are like quite tight. So if I push this in, that's a one-way street. So I definitely first want to test the LEDs. But we can quickly check if this one fits. So this is basically the mount for the ender wire. So this is this part here on front that I made. And there are these two ears, they call it. So these basically go in here, and then I think the intention is to put a headset insert in here, in the middle. So let's mount these, and then we need to headset insert that. And I think on this side, we forgot the two headset inserts. So let's M38. Oh no, that means we have to get a soldering iron out again. And I quickly need to get some inserts. I think this is the part I replaced. I think we did it in the original part. But I was like, I couldn't be bothered to remove the inserts from the old part. But even then, I think I feel like we would be short like at least two inserts because we need two more inserts now, right? My cable's hanging there. Okay. This one. And now the funny heatset inserts here on the front. Half in one part and half in the other part, but it works well. It works well. And not sure what kind of screws we need here. Whatever this screw is. I think this is a M320, that's 12, 20, 20. Before you do that, I see there's a little bit like of overhang that's not super nice. Okay. I used the brim for this part and like similarly like I brimmed the holes close. Okay. That's the whole MMU. I mean, here we now need to do the bottom tubes. Oh, yeah, it's not super flat here, but it will basically be held up here. And the diffusers, basically, we have to take this part off, put the diffusers in. So you basically have the diffuser in here. Yeah, this is like really like this is if I press this in, like this will never come out again. And this will look like this basically. And then here's the aluminum extrusion, so you see the LEDs through the diffuser. Yeah, this is like really, that's like, if I really push this in, this is a one-way street. Yes, super tight. I'm not actually quite sure why. I think it partially has to do with the top here. And also with ABS shrinkage is my excuse. It does make it a lot better. So we will push this in and then this will be in. But that's next time. Like we first want to test the LEDs because like if you push this in, like it will become really hard to reach the LEDs if they don't work for whatever reason. So everything step by step. So next steps. I think this is like a very good point to kind of end today's stream. We are done with the hardware sampling, but also like kind of at my natural end of stream. Yeah, sometimes it jumps, like if I pull it here, it jumps some teeth. So essentially we need to like tension that a little bit more. Let's quickly do that. I'm not sure if I can tension that more. I think this is already the bottommost position it can be. Yeah, I'll just like push the servo fully down. But might also be not skipping steps if the servo actually drives it itself and I'm not like pulling on that thing. Because now it's like super loose, of course. But like if this is pulled here, like it should be relatively strong. Okay. Now I have to kind of skip a bit. Okay. There's no okay. We'll figure this out. Like we need to run the servo, I think, to really see if this works well. Oh, this part just broke. That's a bummer. That's a bummer. Wonder if I can super glue that. I will super glue that. Not really essential. Um, Need a bit more. I'm not gonna close it up now, just to let this dry a bit more. I don't think this is usable though, it's a bit crooked. Like this, it should work. Give a little bit extra glue from the outside now. Yeah, it's a very tiny part there. On the other side, it's a lot deeper. Here it's very shallow, so it's a very weak spot, I think. Okay, nevertheless, I will not put this in now because then it will I will glue everything together. So next steps. The MMU is kind of done. So my next is, yeah, this is ABS. I can also use acetone. I don't have acetone, to be honest. So super glue it is. Next steps. So this unit is kind of complete. So the next step would basically be to work on, I kind of want to, two options are, like we can kind of like flash clipper on this and just verify the function of everything, right? That the switches work, that the LEDs work. I think that's kind of like my preference. So next week, I wouldn't install Happy Hair yet, just like flash clipper and kind of like make the thing do stuff. So I think that's the next step I would do. And then after that, we still have to work on the tool head. So I already printed some stealth burner parts for the filler matrix, I think it's called, which is basically a stealth burner mod with a cutter. So that's then basically what we will install as well. So I think next stream, let's just make the thing work. Maybe we can play around with Happy Hair a little bit, but we don't have the tool head configured yet. Should still work. So I think, yeah, next step, just make this one work. And if that works well, and I think that will take also one stream to, like, you know, install Canvas and get that up and running. If this is all fine, then the next step would be the stealth burner, and then technically it should work. So I think we need at least 2 more streams to make this all fully functional. But I'm very happy with this, how it is already. And I think this looks pretty cool on the Switchwire as well with the matching color here. So excited. Cool. Enjoy your evening, enjoy your weekend, and see you next week. Bye.